Good morning, everyone. Happy Thursday. You have made it to the Lighting Retrofits and Audits class with Eric at the Lighting Design Lab. I am Katie, co-worker of Eric at the Lighting Design Lab. And we are going to get started. It's 10:01. And just before we do get into the material, just in case you haven't been on a webinar with us before, you're all on mute, but you are more than welcome, encouraged, in fact, to use the chat feature to ask questions, and we'll interrupt Eric in a real awkward way while he's talking and ask those questions. We also have some online polls. You get to, click your answer, and we'll see the statistics. So that's kind of fun in the presentation. And at the end, after it's over, there's a short survey for you to take. Let us know how we're doing. And just a reminder too, this is being recorded. We'll have the recording and the slide deck that Eric's going to show you available on our website within about a week. And there's our email address if you think of anything after the fact to talk to us about. And it's just a reminder slide. We are called the Lighting Design Lab, but we're part of Seattle City Lights. Probably a lot of your utility, electric utility. And just for those of you who don't know the Lighting Design Lab, we work with all sort of segments of the lighting design and broadly building facility folks. And with that, Eric, take it away.
Thanks, Katie. Appreciate it. Katie will be coming back with some polls that we'll do periodically. So if you enjoyed that, you'll get more of Katie as we go. But now it's just myself. Yeah, lighting audits, retrofits. And then we're also going to do an overview of LLLC basics. And if you don't know what that is, hang on, folks, because you're going to find out. I love this slide because it kind of keeps me humble, if you will. Not everybody's highest priority is great lighting. And this picture I actually took in a restaurant, albeit a humble luncheonette type restaurant, but clearly they were willing to sacrifice the lighting so they could get their radio in. I get it. So when you walk into a space, don't assume that lighting is everybody's biggest concern. A little about me. I've been at the lab since 1995. I've seen lots of changes. I love lighting. I've been doing it for a long time, and presenting classes, doing consults, writing articles, all kinds of great stuff. So I'm kind of as they say, a mile wide and an inch deep when it comes to lighting. So ask me anything. I'll probably have something to say. So what are we going to talk about today? Overview of procedures around doing audits and lighting audits. Look at some common retrofit options and what things to be aware of. And then we'll touch on LLLC, which, spoiler, is Luminaire level lighting controls. I also love this picture because, a lot of times when you're doing planning a project, you say, oh, let me see the drawings, and you look at the drawings, and then you say, no, you got to look at the as-builts, and so then you maybe look at the as-builts. But guess what? Sometimes you actually have to go and look in the space because people find all kinds of amazing ways to change lighting. I love this. This was a troffer style fixture, which would have had fluorescent tubes in it. They managed to cowboy in a little piece of track lighting. So you just never know what you're going to find out there. All right, so we have our first little pop quiz, and I don't know, Katie, are you going to take over? Do you want me to?
No, okay. I'm going to start that. let's see. Launch. Okay. Eric, do you want to read the options?
Yes, and I just as a FYI, so I don't see it on my screen. I see the green pop quiz, but I don't see the blue. But I think it should be the same. So yeah, how many of
Yep.
you have done lots of audits and retrofits? Uh, do lighting but want to know more about existing buildings? Are a contractor and want to know more about lighting? Um, are new to the field and want to know every aspect and thought this was a cooking class. So we'll just do the little poll here and
Yep, we've
get
got
a
about
sense.
almost 100% voted.
Oh, great.
Yeah, I'm just gonna give another 5 seconds, see if that last vote will come in.
Okay.
And we're gonna close it up. And I'm sharing it out, but you can't see the results, Eric?
I can see them on a tiny little screen, so it looks.
I I'll go ahead and let you
All right.
know. 60% of our attendees currently do lighting, but want to know more about existing buildings.
Great.
40% have done lots of audits and retrofits, so maybe we're going to get some good questions.
Okay.
Nobody thought this was a cooking class.
Okay, that's progress.
Yeah,
So check. That's a win for our marketing team.
yeah. So
All
that we've
right.
got a contractor too, and someone who's new to the field.
Okay. Well, we'll have a little something for everybody. Um, even, and I've noticed this on projects where, a lot of times you'll be doing a project, you have expectations about, what's promoting this. Why is this retrofit being done, or why is this audit being done? And a lot of people say, well, I want to save energy, which is admirable. But really, what they're looking at is saving costs, saving money, and that's just an important business decision, and there's nothing wrong with that. In fact, it's good business practice to cut down your operating costs. Um, but if the primary goal is to save money, that's going to put you down one sort of path. If you really are trying to save as much energy as possible, that may offer different decisions. I could walk into almost any space and save energy. It may not save costs. There may be a lot of price to pay for certain, shaving off an extra 5 or 10%. Um, so it's just good to know what the motivation is. It's also possible uh, that the lighting just isn't performing well, um, and they just want better quality lighting. Maybe there's a productivity issue going on. It could be the space has changed use, and so it needs to be different lighting. It could be that it's just timing. The lighting's aging out, and it's just time to change it. And so they're not sure. Well, okay, we're going to change the lighting. What should we do? Um, it could also be they're doing some sort of construction and there's a code requirement. The lighting has to change to come up to current code. Ideally, it might be all of these in some aspects. So you just don't want to assume that the the primary goal for the client is to save as much money as possible. It may not be, although that certainly should be part of it. And then, often, especially on bigger projects, there's going to be lots of different parties involved, and they might have different priorities, and they're not necessarily working at cross purposes, but you just need to know that the emphasis might be different for different constituents. So, for instance, you have an owner who's more concerned with long-term costs. They own the building, but they're bringing in a new tenant, maybe. And then the tenant, maybe they want to promote their green status. They want to say, yeah, we're working in a space that's, really green or something along those lines. The engineer might want to maximize energy efficiency. You may have a contractor who's concerned with keeping first costs as low as possible. You might have a facility operator who's very concerned about maintenance. They don't want to put a system that's going to be hard to maintain. User groups, their primary concern is highest quality. They say, we want good lighting. And then the architect, they might be concerned about how it looks. Um, hopefully everybody gets what they want, but you you can't assume what the priorities are. So at the beginning of a project, it's always good to go out and do a preliminary survey of some kind. And often we'll get called in, someone's doing a retrofit of a building, and what we hear about first is the hardest part. So if we focused all our energy on, what the client is reaching out for, we might think, oh my God, this is going to be an impossible project. But then you go out there and you realize, 80% of it is pretty easy. There's just some areas that are going to be difficult. So you don't want to focus all of your effort on that right off the bat. Another thing that we've seen is sometimes people say, oh, we have to change all the lighting. And maybe they want to say everything's got to be LED, just sort of arbitrarily. And we've seen this on some fairly new facilities, and they might have an area where, yeah, you can change pretty much everything to LED with no problem, but there's a couple spaces that are going to just be really difficult to retrofit. You pretty much would, one thing in particular I'm thinking about is some bollards, some exterior lighting bollards. Pretty much nothing you could do to retrofit those effectively. So now you're tearing those out and putting in new ones, and that's like 2% of the project, if that. So maybe you say, well, look, let's do everything, and we'll just leave these until they're worn out. Another thing you want to always ask the client is, how do they like the existing lighting? So if you're coming in on a project and they say, yeah, we really like the lighting, but we just wanted to convert it to something more efficient, that you want to kind of have the lighting be at least where it is, or maybe if you can improve it. They might say, well, we really don't like the lighting. So you want to change something about it, and you need to ask them what's questions about how it would change. So all that just so you have a reference point. In terms of cost effectiveness, you need to kind of find out how good a candidate it's going to be and how cost effective a change is going to be. Maybe you have to change it anyway, but at least it'll give the client an expectation. So cost effective projects usually have long hours of operation. The lighting system is older. Electricity, there may be high energy rates. There may be a whole range of things. Like for instance, take this. This is looks like some old server room of some kind. So probably long hours of operation. It may be that they have busy during the day, maybe 2 shifts, and maybe 1 shift there's just someone maintaining things at night. You could walk in here and say, wow, it's really bright. And they're like, well, we need it really bright, but it might be 120-foot candles. I've walked into similar spaces where we're getting well over 100-foot candles. And, it's just a lot of light for an interior space. You could probably cut that down by half, and it would still feel like a nice, brightly lit space. So those are opportunities that, you need to be aware of. Another thing that you want to look at is, are there any opportunities for daylighting? I've walked into spaces and seen skylights that were covered over. Or maybe they should have controls. Maybe people come into the space every hour or two, check some things, and then they go off and do something else. And just for convenience, they leave it lit in between those times. So sensors could be brought on. Places where it might not be as cost effective. The facility has short hours of operation. We see this in theaters a lot, sometimes churches, where they'll have maybe the sanctuary or presentation space that uses very high wattage light sources, light fixtures, but they're really not on that much. So the wattage savings could be high, but the kilowatt hours would be fairly low on an annual basis. It may be that it's already a green facility, and so there's not a lot to do. Or maybe it's been retrofitted recently. We see that people say, well, I want to convert to LED, but it was upgraded to modern T8s maybe within the last 10 years. So there'd be some savings, but not very much. Or maybe the energy rates are low. So there's any number of reasons where the costs there might not, they could upgrade, they could retrofit, but there might not be a lot of cost savings. So as an example, we've got a couple of spaces here, which is likely to be more cost effective. Here we've got this big stadium. Each one of these is 1,200 watt stadium lights. And then here we've got a community center, and maybe these are 250 watt or maybe 150 watt metal halides. So your wattage is very high here, but guess what? This facility maybe has 14 hours a day. The space is lit. So if they can put in a more efficient fixture, they're going to see a lot more savings in this space, which might only be operational, a couple dozen times a year, where they light up all these lights. Here's another example. Similar spaces. Here's a office building lobby, and here's a hotel lobby. This one, let's say they have similar power requirements, but this one, they're open maybe 7 in the morning till 6 at night, if that. Whereas here, this is 24/7, 365 days a year. This space probably looks like that. It may be they have a nighttime setting where some of the lights go off between midnight and 6 in the morning, but possibly not. So again, very long hours of operation. Big box store or warehouse. Again, the big box store might be 12 hours a day. The warehouse might be 24 hours a day, or it could be different. It could be that the warehouse is really just sort of during the day when the office is open. Maybe they have warehousing, but after they close, the warehouse goes dark all night. Whereas the big box store might be like a grocery store or something that has 14 or 16 hours a day. 7 days a week. So you just have to find these things out. So, some types of facilities are very simple. You can walk in, get a sense of it. Other times, it's a complicated, maybe a campus type of building, and you need to do a very fairly detailed audit. But one thing you can do is identify similar spaces. So maybe it's a school. Well, it's a big facility. They've got lots of different spaces, but a lot of the spaces are very similar. So every classroom is pretty much the same, and there's lots of them. You want to look at the circuiting. Check out what the current recommended light levels are, and we'll talk about that a little bit later. And those could be driven by building codes, local codes, or some other recommendation. Some things that you might want to take with you when you're going out to look at a space is you might want to bring a light meter with you. I don't, really put too much stock in light meters, but sometimes it's good to have them as a point of reference. We'll talk about it a little bit later. Some sort of measuring device, measuring tape, or laser. There's laser measure. One thing I've found is in bright spaces, a house or a gymnasium during the day, they're not always helpful. And if you're doing exterior during the day, they're almost useless because it's so bright out. You can lasers pointing. So a measuring tape might be good to have with you, especially if you're doing exterior, maybe 100-footer. How far is it between the poles? Notebooks or a tablet, tape recorder with a transcription, camera with a zoom. We'll talk about that in some detail here in a minute. Binoculars can be handy for large spaces. Personal protective equipment, a counter, so you can easily count and not forget how many lights there really are in that large warehouse or classroom. And then if they're looking for a utility rebate of some kind, it doesn't hurt if you have the form with you, so you can get a sense of how that's going to need to be documented. So that's what some things you might want to bring. Then you want to go and document the lighting systems. So again, check light levels. Existing doesn't hurt. They may say we want more light, but it's always good to know how much they currently are getting. What types of luminaires, the mounting, the placement. One thing I've seen sometimes, especially in industrial or spaces, is you may have the same fixture mounted lots of different ways. Like it might be mounted, you might have a sort of what they call a wraparound fixture, which is a couple of tubes that have a plastic lens on them, and they could be hanging from the ceiling, they could be mounted to the wall, they could be mounted directly to the ceiling, but it's really all the same fixture. And so that can make it kind of easy to keep track. What kind of lamps or light sources do they have? What's the color? Is it consistent? Does it change from one kind of space to the next? And what's the wattage? Talk about that too. Ballast types, voltage. What are the daylighting conditions? Could they be improved? Are there any opportunities? Are the luminaires already retrofitted? A lot of times we'll see, you walk in and you can say, oh, this space was retrofitted, 15 years ago or 5 years ago or whatever. And are the as-builts consistent with that? Did they show the retrofit? Usually not. What controls are in place, occupancy sensors, timers, photocells, etc. And then the room reflectances, and we'll talk about that in a minute. So another thing, once you've looked at the luminaires, it doesn't hurt to look at the general condition of the lighting. Is the lighting in good shape? Or they might be thinking they want to retrofit the fixtures, but you're like, we're going to have to replace these. And again, look at the controls. They may have controls, but are they working? Then you want to look at the building condition in general. What type of ceiling is it? Is there access to some of the electrical? What's the access going to be like? Again, back to daylighting opportunities, reflectance of the interior surfaces, and it doesn't hurt to look inside their maintenance closet and get a sense of, do they have spare lamps, spare fixtures, and that can also often help you determining what existing wattages and fixture types are. Okay, it looks like we have another pop quiz.
Woohoo, okay, let me open this up. Launch, there we go.
All right, so which of the following suggests that a retrofit is likely to be cost effective? And there could be more than one correct answer here. The facility has long hours of operation. Measured light levels are higher than recommended practice. A community theater stage has 50 500-watt lights. A hospital parking garage with over 30-year-old lights. And the customer is going for LEED existing building certification.
And this one's a little bit of a thinker.
And there could be more than one.
Yep. I'm gonna give about 5 more seconds. Lots of voting going on.
Excellent.
All right, 2 seconds and close the poll. Okay, Eric, here's what the results were.
Yeah, I can see them here.
Oh, good, okay.
Yeah, it looks like people got it generally right. Facility has long hours of operation, yes. Measured light levels are higher than recommended practice, yes. This was a little bit of a tricky one. The community theater stage is 50 500-watt lights. That seems like a lot. But again, they may only do 4 or 5 productions a year, maybe the 2-week run at the most. So that's mostly dark. They're not using them on an annual basis. And then we have hospital parking garages with 30-year lights. So they have long hours of operation, very old lights. And customers going for LEED existing building, that was a little bit of a mulligan there, I didn't really explain what LEED is. LEED is a standard for uh, energy efficiency. So if a customer is going for LEED existing building, it means they're going to be very aggressive about their energy savings. So they might do some things that would be um, slightly outside of what would be cost effective, but they might do them anyway. So that's a case where, you have to ask the customer about that. All right, moving on. So documenting the existing light levels. Um, so what is being proposed, and I've gone to clients who are like, oh, we need 100-foot candles. And like, okay, where did you get that number? It just seems like an awfully round, high number. Then you could say, well, what is recommended? So they might be like, oh, well, our contractor said we need 500, or we need 100-foot candles. So it's like, okay, so what's he basing that on? Are the light levels consistent throughout the space? And they might be like, oh yeah, we just don't have enough light here. And you walk down in a warehouse aisle and you find out that 2 or 3 of the lights are out. But in the aisles where the lights are all working, it might be pretty significantly higher. So they're responding to the problem area, but it's an unusual. So again, just doesn't hurt to just find these things out. And are generally the users happy with the light levels? They might be like, well, this is not near enough light, but you walk in, you're like, seems pretty bright in here. So maybe there's some other issue. Or they might be like, it's fine, but you're like, oh my God, this is a safety hazard. So you need to do a little education. So it doesn't hurt to have your own opinion and not just go based on blindly on what the client says. So when you're documenting the existing luminaires, we talked about camera with a zoom lens, and everybody's walking around with a smartphone now, so they're thinking, well, I've got a camera with me, and it kind of zooms. So here we've got a case where we've got some lights that are about 15 feet off the ground. So you could, and you're like, well, what is the existing light? And they're like, we don't really know. They were here when we moved in. So you're trying to find out, and you say, oh, there's a little label up there. So you zoom in on it, you take a picture. Well, when you get back to your office and you zoom that in on your computer, you can't really read that at all. And this is I did with my nice Apple smartphone. Here's one I took with an actual zoom lens, but it was just a regular little Instamatic camera, but it had I think a 12x optical zoom. So I can zoom in on that label, and I get back to the office, I can tell all kinds of things. I can tell who the manufacturer is. I can tell the model number. I can see the wattage, maybe some bits about a date, maybe when it was installed or manufactured. So there's lots of things you can get. And if you had to get a ladder, so, just on a quick walkthrough, maybe this is preliminary, or maybe it doesn't merit a full-on audit where you'd actually get a lift out, or might be quite a hassle to get a ladder where you could actually get up there and read that label. So this would just save you some trouble. Could do it with binoculars too, but it doesn't hurt to grab that picture. Here's another example where this was a exterior canopy lighting. The client was pretty sure they had 100-watt lamps, and so they wanted to retrofit them to, LED. So I took out my trusty little zoom on the spot. Took a picture, was able to zoom in. I could tell the manufacturer. I could also tell it was a 70-watt, not 100-watt. So it just helps them calibrate their expectations, if you will. And the difference could be the difference in, certainly how much costs how much energy they'll save, and what kind of incentive they might get from the utility based on that energy savings. So it doesn't hurt to have that right with you. Again, getting a ladder out would have been, half an hour if it could have been done at all. Another thing you want to know is, how is the light delivering? How is the luminaire? How's the light fixture delivering the light into the space? Is it a direct luminaire, meaning 90 to 100% of the light is coming directly out of the fixture? So here we have a cross section of a 2x4 troffer, very common type of fluorescent fixture in a space. It's going to send most of its light down into the space. Recess can does the same thing. High bay, warehouse light, even these cylinders, they're all putting light directly down into the space. Is the space being lit with indirect luminaires? So most of the light comes up out of the fixture, whether it be, sometimes you have a bowl-like fixture like in a lobby or maybe a, corridors, and it glows a little bit, but you're really not getting much light through that lens. It may be, 7%. So most of the light is bouncing off the ceiling, wall-mounted, not uncommon, and certainly linear pendants. And then often you'll have a combination thereof, even this prismatic fixture. Sometimes, depending on how they're, this is a high bay type fixture, industrial, but you might have them in food courts or concourses or big box retail. Sometimes they glow quite a bit. It just depends. A better one, if their quality is actually going to send most of its light down, but if it's sort of a cheapy, it might be sending a lot of light out to the side, and that's something you'll just have to find out. Again, this may be delivering 30% of light. You just aren't, you can't be sure, but there's going to be variations on direct, indirect, whether it be a pendant, wall mount, or some other kind of decorative. Why do we care about this? Well, let's say here's a picture, and you've got a little restaurant here, and they've got these existing fixtures, and someone had the great idea of changing them to this. That might be perfectly fine choice. It may be in line with what their expectation is, but what they will get, they'll take these fixtures, send out light in all directions uniformly, so it sort of lights the entire space. Maybe they don't like that look. Maybe they want to de-emphasize the ceiling and put light down in little pools on the tables, because that's exactly what they're going to get with this. Most of the light's going to come straight down. It'll also be slightly less efficient unless it's a really well-designed little cylinder. So they may get less light than they expect. It's just a case of, if they say, hey, we're going to take these out and put these in, you can just have that conversation with them. Say, hey, that's a great idea, but you realize you're gonna have darker walls, you're gonna have pools of light below the fixtures, and they might be like, great, that's exactly what we want. Then everybody's happy. You want to, beyond just looking at the fixtures, it doesn't hurt to take a couple of them apart, find some that look like they're, typical of what you've got, and pop one open. You may find that there's worn out components, there's stuff leaking. Does that mean there's water coming, intrusion from somewhere, or we have components dripping things? Is it superficial, or is the fixture damaged? How are the gaskets? Things like that. You can just tell a lot just by opening up the fixture. And it may be that, they want to retrofit them, but you're like, you know what? By the time we replace all these sockets, put in new wiring, blah, 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 new lens, you should really just replace the fixtures. Then you want to take a look at some of the electrical components. Do we have 277 volts, or is it 120 volts? How old are the ballasts? This is less and less of an issue, but what you're going to be seeing a lot of times in commercial spaces is fluorescent lighting that you're maybe retrofitting in. If it's an old facility, a ballast like this, pre-1979, you have to assume it contains PCBs, which is a hazardous waste disposal. If it doesn't say no PCBs, you have to assume it has PCBs. So most of the newer modern ballasts will say it right on there. You still may need to remove, the utilities often want you to remove the ballasts, and you'll have to dispose of them properly, but it won't be necessarily hazardous waste. And you can't just open one fixture. Here's a case where, this was all in one room of one building, and we opened few fixtures, we found all kinds of funny things. We don't need to get into all the details about what all these mean, but here we have a 2-lamp normal ballast factor, 2-lamp low ballast factor, 3-lamp normal ballast factor, even though they were 2-lamp fixtures. We saw some battery backup. We saw some 277 in there. So, all of this will figure into what their current wattage is, how the fixtures are performing, and what they can expect once they replace them or retrofit them. Then you want to take a look at the controls. They may have controls on site. It may be that they're substandard and that they'll just need to replace them, either because of compatibility issues or just because they're not going to be up to current code standards. Like, for instance, these mechanical time clocks are no longer allowed. Occasionally, especially in industrial spaces, but even in campus type settings, we'll see breakers are used to control the lights. Someone comes in at 6 in the morning and flips all the breakers on, and the lights just stay on, and that's not allowed anymore. They may have, occupancy sensors that have components that are failing. Exterior photocells are a real common ones to get beat up, especially if they're out in the elements. You just plan on replacing those, or old dimmers that aren't going to be compatible with the new modern lighting. Sometimes you want to talk about an easy win. So this is a case where you don't need elaborate controls here. So these lights are on during the day, and you could almost just put it on a timer. Say, look, after 9 o'clock, or every day the lights are going to go off until 6 o'clock. It's not a complicated space. There's just really no reason. And what was ironic, so I'm always taking pictures when I'm out traveling. So here's this space. So when we walk to the end of this, we get into here where we actually might need the light, and the lights are off in here, but they're on out here. It's just, kind of crazy. So anyway, the lighting, it's a curse. So you want to look at the existing lighting system, and part of that is looking at the room surfaces, because the interior space surfaces are part of the optical environment. And surfaces help mitigate brightness ratio of luminaires, control contrast, and they can also just add to higher light levels. And you're sort of thinking, well, this seems like interior design. This really isn't, I'm here to do electrical stuff. But look at how this can help you or hurt you. So here's a little model I did of a simple 2-story building, no daylight coming in, so maybe it's after hours. And we've got similar offices, first floor, second floor. And this space looks darker, this one looks brighter. And the reason that it looks brighter up here is because it actually is brighter. It's the same lighting on each floor, but different reflectances. We've got, off-white, yellow, and a bright ceiling and the floor. So all these surfaces, so how does that work? And occasionally, depending on your skill level and how involved you are with the client or complicated it is, you might actually run a calculation. Or maybe you've got some software that's pretty easy just to plug in your number of fixtures, the number of fixtures, and maybe a little bit of information about the fixture, and you hit a button and it says, this is how many foot candles you'll get in this space. And you're thinking, wow, magic. But the typical default surface reflectances on a computer model would be 70% for the ceiling, 50% reflectance for the walls, and 20% reflectance for the floor. And so given this certain, in this case, number of fixtures and the volume of space, I would get about 35 foot candles in this space if I just ran that number. And then my contrast ratio would be about 10 to 1, 11 to 1. So the brightest spot to the darkest spot. If I am actually using a dark ceiling, maybe they're taking out the acoustical tiles and just leaving open exposed structure. They're going to spray it out dark blue, or maybe it's wood up there or something like that. It could easily be low reflectance. Maybe the walls are low reflectance. Maybe it's brick, and they love the look of the brick, and that's fine. They want brick, or maybe they're using concrete exposed concrete, and maybe the floor is stained concrete, so it could be low reflectance. So instead of 35-foot candles, they get 23-foot candles. That's a lot less light. That may be acceptable to the client. You just need to this should never be a surprise. If you have high reflectance ceiling, high reflectance walls and floor, same situation. So here in this case, the floor is bamboo floor. We've got high performance ceiling tile. It looks white, but it's just higher reflectance, and we've got a lighter surfaces on the walls. I get more light. So that means I can either be more aggressive with my savings. I can put in a few less fixtures or lower wattage fixtures, save more money, save more energy. If this is their target light level, 35-foot candles, I've exceeded it. This is all extra light. I don't need it. So knowing these reflectances and what the implication is going to be can either help you or hurt you, depending on how things are going. And you're thinking, well, when's this really going to happen? But this is pretty common. So here we have dark wood floor, dark carpeting, saturated wall colors, concrete. Who knows what the ceiling is? Maybe exposed structure. They've sprayed out black. So it can come back to haunt you. And it may be that the clients can say, well, this is what we want. And then you just have to have a conversation with them to say, well, your expectations of savings with lighting should be lowered a little bit. Here's some industrial spaces. I mean, they just sprayed everything white because they know that they're going to get more light and also better contrast ratios. If we look here, 7-to-1 or 21-to-1, this might be appropriate for a restaurant or a nightclub, but not so much a high activity area. Again, we can have low reflectances or high reflectances. It's just free lighting. So how do you tell what the reflectances are? Well, one way is to have your trusty light meter. And what you do is, let's see if I can do this. You take a light level reading for the light that strikes the wall. You hold your meter up, take your light level reading, and then you hold it out about a foot from that same surface. Now in this case, I'm right near a window, so it wouldn't be great. I'd probably hold it back a little farther so I wouldn't get too much daylight on the meter, and then you get your light bouncing off. And then you do simple calculations. So we've got maybe 80-foot candles striking the wall, 20-foot candles bouncing off the wall. You run the numbers, and you can tell that you've got about 75% absorbed light. Another way that you can find that out is if they're planning to if they're doing, say, a remodel, say, well, what kind of paint are you using? And then it might be like, oh, we're just using off-white. Well, if the space is painted with this is going to look like off-white. And sure enough, its reflectance is about 63. So it's, within the realm of about 50% reflectance. So it's pretty good. They might actually be using this, which is a little darker, perfectly common. There's 50% reflectance. We go up here to this one, still off-white, 75%, 74% reflectance. So it'll say on the back of that color chip what the reflectance is. So that's just another way you can find out. And that may be what you find out if you go and look in the maintenance closet. They might have some extra paint lying around that they would use for touch-up, and you can look at the paint and find out. So that, again, it's not really so much interior design, but you're just letting the client know some things. So here's another question. When's the best time to audit exterior lighting? During the night or during the day? It seems like a trick question. But you go out there at night and you'll see light, and you might see some things. But if you went out there during the day, you might find this. Wow, we've got lights on all day long, and this one's off. Does that mean it's burned out, or does that mean it's the only one that's being controlled properly? Another thing you can tell, if you go out at night, all you see is this bright glowing thing that's hard to look at. During the day, you can say, wow, this lens is really failing. It's yellowed, it needs to be replaced. We're losing 30% of our light on this fixture. So those are things you can tell during the day that you wouldn't necessarily be able to tell at night. Another thing you can tell, especially if you've got high mast or fixtures that are high up, you get your trusty camera out, zoom in, and you can see maybe there's rust in places. In this case, it's not really failing, but you could tell if it was, and it may be like, well, you want to replace the lighting, but guess what? You're putting it on a structure that needs to be addressed. And that, why put new fixtures on failing structure? So some other analysis tools that you might want to have in your bag of tricks, or at least possibly if the client asks about it, or maybe know where you can get them if you need them, are a luminance meter. So, I mentioned my light meter. This measures illuminance, and that tells us how much light is striking a surface, and that tells us foot candles or lux. But luminance measures how much light is coming off of a surface or from a light source. So someone might be complaining about lenses that are too bright, or maybe there's glare somewhere. Maybe you're doing site lighting and there's light trespass concerns. This will help you look at those lights and see how much light is actually striking that surface or coming off that surface. And we measure that in candelas per meter squared. You might want data loggers. They're like, oh yeah, we're constantly, we're going to save a ton of money if we retrofit all our warehouse lights. We're putting in controls, and lights will be off all the time. But you might find out that most of the aisles are on a lot. Even though the client thinks they're not. People go in and out, or maybe they could make the space more efficient if they just restacked some of their product, and they could have sections of the warehouse that were not used as much. Anyway, the data logger tells you when people are in the space, or at least when the lights are on. Spectrometer, that's become an issue lately, is what's the spectral power distribution of the light sources. Flicker checker, as we get with LEDs, some of the, especially the poor quality LEDs, sometimes they flicker in ways that can be either annoying or that can be actually a real productivity problem. Thermal imager, if they're having premature failure of components or systems, you can say, oh yeah, this thing's really getting hot, or you can say, wow, you've got your air conditioning is blowing on that thing constantly. That's why it's you're not getting good performance. A UV meter, and sometimes people just will wear a GoPro and they can turn that on and off, and they can document the space efficiently. So we talked about how much, looking at the space, people have ideas about how much light they need, but how much light do you really need? I love this picture, circa 1939, Nela Park. Here we have the captains of industry sitting around 200 foot candles. It's a revelation. They're happy to have it, and part of the reason this is a revelation is because previous to that, all they had was dim incandescent lights, and so now they could have lots of electric light. Notice that they've closed the blinds. So one thing you could do in this case, because sometimes the windows you just get boarded over, or skylights get boarded over because they don't need them anymore. But now we're seeing things differently. We actually want to bring daylight into spaces, and it's also potentially a free source of lighting energy. Yeah, just the standards change. So here's a case where we go back to 1972, the IS, the Illuminating Engineering Society Lighting Handbook. So for typical office space, general office reading tasks, they wanted to see 150-foot candles maybe, or 100-foot candles if it was a simpler task, or maybe as low as 70. But today, and this is the most current edition, but this will give you a sense of where things are the trend. Here in 2012, we went down, we look at offices lighting. This is from the IS handbook, 10th edition. And we see reading tasks, different kinds of reading tasks, but here, black ink. And we can see it's 300, or maybe if it's blue ink, it's 400. What is that? 300, 400, that sounds like it's higher. These are lux. And on the other one, they're foot candles. And so you're thinking, wow, how can I keep track of that? So lux are the sort of the new thing. The good news is 300 lux is about 30-foot candles. 400 lux is about 40-foot candles. So we went from maybe as low as 70 down to 30 or 40. That's cutting it about in half, and those are the current recommendations. So this is where you want to question, your client, if they're saying, oh, well, we look at our standards and they say that we need to have, every classroom needs 80-foot candles or whatever it is. And you look back and you see that standard was written back in the 60s. So you want to say, well, this needs to be updated a little bit. And you can show them what the current standards are. All right, so another thing is, so how much light do I need? Then the next question is, how much light will I get? And it's going to vary depending on how many fixtures you use, the wattage of the fixtures, the lumen output of the fixtures, a whole range of things. So here's a sort of common high bay type fixture, which you might be putting in a gymnasium or industrial facility, but you might see similar kinds of fixtures even in like a food court or a big box retail, or a like a big high volume airport concourse kind of space. And this fixture has all these different possibilities. So we look at the fixture, and we can see it comes in anywhere from 9,000 to 30,000 lumens. Lumens are a quantity of light. We can have different kinds of reflectors. We can have different kinds of lenses, voltages. In this case, they all come dimmable, but we can have different color temperatures. We'll talk about that in a second, or different color rendering. Again, these are how, is it going to be warm light or cool light? Is it going to be, good quality or excellent quality? And depending on which you choose, you can get, so our 30,000 nominal lumens, actually, if you look up here, we can get maybe as much as 29, in this, I have 28, but it could be as high as 29,000 lumens. So that's pretty much what we would expect. That would be if we have 4,000 kelvins, 70 CRI, color rendering. But if we picked a different combination, maybe we want something warmer with higher quality, we're down to 19,000 lumens, maybe almost 20,000, 19,700. So that's a lot. That's a big change. It's a lot less light. Almost the same fixture. So we got to be careful how we specify. And let's just look here. So we go from, I think, so this is a poll, but I think what we'll do is just, for the sake of time, I'm just going to go through this. We won't take the poll, but it talks about, how much do we know currently about color rendering and color temperature? We're just going to go through it real quick anyway. So the color, here's two light sources that would be used architecturally, both nominally considered white light sources, and we can see very different effects from them. One looks very yellow, one looks sort of neutral white. But the main thing is we look at the cars here, red car, blue car. Here we see two sort of muddy, kind of brownish cars, but they're the same So there's, depending on what light source we choose, we can get very different effects. One of the things we're noticing is color of the light, and we call that color temperature, or CCT, correlated color temperature. We use the Kelvin scale for that. We just, instead of Fahrenheit or centigrade, it's kelvins. And natural light sources, daylight, sunlight, we assign a color temperature to. Incandescent or candlelight has a color temperature, very warm. Incandescent light, high pressure sodium light. So a lot of these electric light sources have just one light source mostly. Fluorescent lighting, you can choose what you want. And the thing about LEDs is they can be almost anything, which is kind of fabulous. And then we see the difference. So we saw rather starkly in that first slide, but we can see here it can even be somewhat more subtle. We look at complexions. That gives us a lot of clues about a space. So if we're in a retail application, or even like a warehouse, if everybody comes to work looking all jaundiced and a little bit ill, we just don't get a good feeling about the space, subconsciously. But certainly if you're involved in hospitality of any kind, whether it be an airport or a restaurant or a retail, you want the colors to pop, you want people to look great. So color rendering, here's one that's 85 color rendering index, 65, pretty mediocre. The good news is most LEDs, generally come at least 70, and sometimes they can get all the way up into the high 90s. There's a cost for that, and I think I'll try to tell you that you don't always need this highest quality for every case. So here again we have high pressure sodium, old style light source, but these were used for lighting roadways for decades. And we can see certain colors are hard to identify, or they just sort of blend. And here's mercury vapor. We don't really use these anymore, but they were used for decades as well, for exterior primarily, but even interior occasionally. And we can see what it does. So what we want is pick a white light source that has good color rendering, and every color kind of pops. So, if we're lighting, say, a parking garage or even a warehouse, 4,000 kelvins is sort of a neutral cool, might be very appropriate color. 70 CRI is good quality. It's it's not excellent, but it's probably good enough so that complexions look good. And we can easily identify different colors of boxes or materials, and do the job quickly and efficiently. Here, but that may not be appropriate if I'm lighting a food court. I might want a warmer color, maybe a little more pleasant. We definitely would want a high CRI if I'm lighting, say, a Target or store, or maybe a Home Depot. This would be good, but for a Target, I might want this kind of light. Need that high color rendering index. We just have to know there's a penalty to pay. We're going to get less lumens. That just may be the cost of doing business. Here we've got the lumens per watt. There's 125 for the 4,000 Kelvin, 70, but for the 3,000 Kelvin, 90 CRI, it's only 80 lumens per watt. That's still a big number. But so just know that. Plus, you might think, well, maybe this is better, but if I put it in a warehouse, I'm maybe not getting the benefit. And I'm going to spend more money, and I'm going to have to put in more fixtures and more energy. Someone said not long ago, isn't lighting getting easier? It's just LEDs now. These are all the possible combinations I could get. Actually, there was more with just that one fixture. So if I'm running a model, I could, I wouldn't use all of these, but I could. It'd be crazy. All right, another quiz.
You want to open this one up? I mean, you want me to? Okay.
Yes. Yeah. No, just the quiz.
Let's just look at it. Okay. There we go. It's open up.
Thank you, Katie. Okay, so what are the benefits of light interior surfaces? Potential to save energy, improve visual comfort, lower contrast ratios, potential higher light levels. And isn't this just interior design, not my area? So how many of these do you think would be the proper answer?
Right, you could pick more than one on this one, right?
Yes, we want you
Yeah.
to pick more than one.
So if you only picked one, you just got a hint. Go back and pick another one.
Yeah.
All right, give it 5 more seconds. 3, 2, 1, close. And here are the results.
Excellent. Okay. Right. So certainly potential to save energy. Now, admittedly, you'd only save energy if you acted on the fact that you could get higher light levels and maybe use less energy, less fixtures or lower wattage. Um, improve visual comfort, yes. Lower contrast ratios would be true. If you have light surfaces, you don't have as much contrast between the brightest and darkest, so some people miss that one. And the potential for higher light levels, again. And then the interior design, yes, no one fell for that one. So that we've made some progress. All right, so common retrofit applications. We're going to look at fixtures that are commonly retrofitted and talk about them briefly. So we have the troffer, 2x4 troffer or 2x2, recessed cans, decorative fixtures, high bay type fixtures, and exterior. So discussion for troffer retrofits always comes around to so-called TLEDs, tubular LEDs. People want to retrofit to LED. They take out their old fluorescent and look at, here's this product that looks a lot like the fluorescent they took out. And guess what? It's got LEDs. So it's great. I'm moving into the modern age. But you know, you're going to find I'm not a big fan of these. They can work in certain limited cases, um, but there's differences between them. Some of them don't have a diffuser. So if you put it in, you'd be looking at all these bright, glary, sparkly LEDs, usually not great. Some have narrow ends, some have wide ends. So I'm going to not get light out of this area. We're not seeing this too much anymore, but some have big metal heat sinks to help do thermal management. And some of them are made of glass. Glass is cheaper than plastic, and there's a whole industry out there designed to make 1-inch glass tubes. So there's trying to use that machinery. But you know, glass has all the problems that we've had with glass. So be aware of that. The other thing is a fluorescent tube puts out light evenly in all directions around it. So here's our fluorescent cross-section of fluorescent tube, and I'm getting light more or less uniformly around it. A lot of the so-called TLEDs, some of them have fairly narrow light distribution, 180-degree aperture, but I'm only getting 105 degrees of light. Sometimes it can get up to maybe 160 degrees with this so-called 240-degree aperture, but I'm still not getting light up. That's not always a problem, especially if I'm retrofitting a direct luminaire or troffer. Usually I want to just push that light down. So it could be okay. But if I'm retrofitting a light source, a luminaire that has indirect and direct, I'm going to have to choose which one I want. And it's going to affect the lighting in the space, and it's going to probably not be a happy solution. So that's the optics. Now we get into the wiring. It seems like it used to be simple, right? I take out my fluorescent tube and put this thing in. Well, there's 3 basic kinds of TLEDs. Ones that in theory require no rewiring, ballast compatible, call this UL type A. Ones where you have to rewire the fixture, disconnect the ballast, we call these UL type B. Another way you rewire the fixture, but the driver is not inside that tube, it's separate. We call that UL type C. And then at some point we have to ask, when does a tube replacement become a kit? And this would be important, particularly if people are looking for a rebate from a utility. So the ballast compatible TLEDs, you got to read the fine print. It says compatible with 90% of electronic ballasts, TA ballasts out there. Well, I don't know what happens to the other 10%. You got to be, so that means you got to look carefully at the existing ballasts and all the ballasts and make sure they're going to be compatible. If you've got a big campus of some kind, that's a lot of ballasts to look at. Beyond that, there's a little fine print delivered lumens per TA lamp. There's application notes. Due to numerous ballast designs and topologies, this lamp should be tested on existing ballasts before mass quantities are installed. Not intended for use in older dedicated voltage instant start ballasts. Well, if you're doing a retrofit, and I should say that instant start ballast is by far the most common ballast you're going to find in the commercial landscape. And if you're doing a retrofit, they're generally going to be older. So not intended. I don't understand this. So they say these ballasts have electronic components that degrade over time and may not be suitable. So yeah, that would be a big red flag for me. Here's one where you rewire. So then you say, okay, this is too much trouble. I'm just going to disconnect the ballasts, and then I don't have to worry about compatibility, which is true. Eliminates concern. Most include integral driver, so there's a driver built into this thing, and are powered directly by the mains as they come in to the fixture. Power, but should be disconnected both ends. The wiring is different. Improper wiring can result. Different products are wired differently from manufacturer to manufacturer. Dangerous conditions. Further, each lamp type may require either shunted or unshunted lamp holders. Well, what does that mean? What that means is that these fluorescent socket holders, sometimes we call them tombstones, are either non-shunted, meaning these two leads are separate from each other, or they're shunted, meaning they're connected to each other. Instant start sockets are shunted. It's either, you can either see the wire or it's done in the factory. Do not use this retrofit kit in luminaires employing shunted bipin lamp holders. Well, again, the instant start configuration is by far the most common you'll find in the marketplace, in the commercial landscape. So shunted lamp holders are found only in instant start luminaires. Okay, well, that's great, they're telling us that, but that's going to be pretty much everything. So you have to pretty much count on rewiring or putting in new sockets. That's going to be a lot of work for a technician to do on every fixture. So now we have remote drivers, still considered tubes because they get power from the sockets. But the good news is sometimes, so you're buying the TLEDs and you buy this little driver and it looks just like the ballast you took out. The screws are in, everything's mounted, same size. So that's pretty good. Usually included, and they're usually supplied by the manufacturer. So that eliminates compatibility issues, but it is more rewiring. Here's a case where remote driver tubes are using the sockets, but no power to them. So we have our power coming in from our line voltage, or the power comes in from the AC, goes into this little driver that we stick on somewhere in the fixture, and now we just have our modified low voltage wiring DC coming out directly into the back of this LED. You can see a little socket there, and there's our tube. So it's using the sockets only as a lamp holder, just to hold it in space. The power comes in somewhere else. We're seeing all kinds of configurations. This may or may not be allowed. And then finally, we get into what would be, by most definitions, a kit, where we have a remote driver, the TLEDs, but they don't touch the sockets at all. They're about 4 feet long, let's say in the case of a 4-foot fixture, but they just have held up by magnets, and the sockets aren't involved. And that's important because certain definitions of a tube are ones where they're touching the sockets, and others where they're not. It becomes a kit, and some utilities only incent on kits. So this would be your sort of most basic kit. If they like the lighting they had, hopefully this will make it look just like they had it before. If they didn't like the lighting they had, this will make it look just like it did before, if you're lucky. Maybe a little brighter, maybe not. Sometimes you get kits where you have a whole new optic, so it looks like a new fixture, but often there's lots of little pieces to put together in the field. All this stuff has to be assembled. You close the door, and now it's like you just had a whole new, having a whole new fixture. They often cost about the price of a new fixture, but the reason you might use it is you're not having to dispose of all the housing, the existing housing. Maybe there's stuff up in that plenum above the ceiling where either just a lot of dirt, or maybe there's asbestos or other things, and this way you're not really touching the plenum at all. You're just all the work is done from below. So there might be reasons why you would prefer a kit over that. One thing though that you might want to think about is maybe they want new lighting. If they're getting all new carpeting, all new furniture, painting, everything, maybe they don't want the same old lighting, even if it, maybe they want a different kind of lighting. Here they have these troffers. They look pretty good, but once you change everything, they're going to look pretty sorry. So that could be time to have that conversation. Here's another case where decorative fixtures, you have these in hospitality lot, apartment buildings, hotels, hundreds of these in a building. So you've got, in this case, maybe we've got 4 compact fluorescents in there. You're looking at the lumens, they're 1,800 lumens each, so you add that up, it's 7,200 lumens. Here comes these LED fixtures. Well, this one's got 2,500 lumens, and this one's got, say, 2,000 lumens. Well, how are they going to possibly be able to compete with this 7,200? But if you look at the efficiency of this decorative Luminaire, the efficiency is 37%. That means less than 40% of the light makes it out of that fixture. Most of the light from those lamps is absorbed in that system. So really, we're looking at closer to 2,600 lumens. And we see fixture A, we'll call it, this our other one had the 2,500 lumens, but those were source lumens. They didn't do the photometric file for this fixture. They just said, okay, here's an LED chip. We're putting in LEDs in this fixture, and it's going to give us, 2,500 lumens. We don't know what's going to happen once it gets out of the fixture, but if this fixture is anything like the other fixture, we're not going to get most of that light out. Whereas the one that LED B that we looked at that only had maybe less than 2,000 lumens, those are delivered lumens. So they ran a photometric on this. They did put it in the laboratory, measured the light coming out of the fixture. So this is actually one that's going to be pretty close to what we were looking for. So you have to look at the luminaire efficiency and light output in lumens, and that's what you'll get if you make any changes. If you say, well, we don't like this white lens, we want an amber lens, you need to then get a different, it'll have a different file. And you can't always just look at the lumens of your light source. So, here's a omnidirectional, it's about 95 lumens per watt. Here's a directional, it's got 75 lumens per watt. So we're thinking, well, this one's going to give me, better light. But sometimes I'm really just looking at light that's going to be delivered out into the space, as opposed to something that might be lumens that might be lost in the fixture, and we'll look at that in just a second. But we want to look at the beam angle and the field angle primarily. So we have center beam candle power coming out at the middle, and when the light drops off to 50%, that is our beam angle. And that's the number that we're concerned with often. If we have an omnidirectional light source, whether it be compact fluorescent, metal halide, incandescent, and we put that into a fixture to try to get directional light. So here we have our 65 lumens per watt from our omnidirectional, in this case, compact fluorescent source. We put it in a recessed can that's only 50% efficient. We're only going to get about 35 lumens per watt luminaire wattage or luminaire efficiency. Whereas, so we can see how this works in the field. So here's our recessed can looking up in there, a couple of compact fluorescents. We have a hole in there to let some of the heat out because they're temperature sensitive. If I stick my head up in the plenum, look above the fixture at the housing, I see a lot of light. Wow, where's this light coming from? I'll tell you where it's coming from. It's coming from these lamps. It's lights that's not going into the space where I want it. It's going, there's so much light up here, I can read the label quite easily. So that's all just wasted energy, wasted light. So that's where I can take an omnidirectional source and put in a directional LED, and maybe I get, I can take out 26 watts and go to 13 watts and get a lot of savings and still maybe get more light than I had. The problem with these, so this is and these are LED replacements for compact fluorescent. In theory, you could just take out your compact fluorescent and pop these in. But there are, of course, some caveats. Would that it was that simple. Simply plug the replacement lamp into the existing ballast. Okay, well, let's see what happens. Well, first I have to look at a compatibility chart. So here's my product. And I'm then looking, I have to get into the fixture, open it up, and see what ballast is on there. And I have this SmartMate ICF, and here it is, the Advanced SmartMate. So it looks like it's compatible, except in one condition. But we don't have that. We've got, say, two lamp, 120 volt, and then we go to try it out. We check, but then we look. Then it says read the fine print. It doesn't work. While each ballast type listed has undergone testing, some have undergone revisions that may have changed the operating parameters. So performing an on-site test before installation is recommended. Well, I did an on-site test and it didn't work. Here's another one. Here's a product that says, here's the large print. Says compatible with most fluorescent ballasts, a little asterisk there. If I go down and look at that, what that says, it says for maintenance and energy savings reasons, this company recommends bypassing all ballasts for permanent operation. So if your plan was to do this retrofit for just temporary, you want to retrofit them for just a couple of weeks and then go back to what you had, this would work. But I don't think most of us are doing that. We want to do a permanent retrofit. So what they're saying is, even though they say it's compatible, actually you should bypass the ballast. And that's a lot of work for each little recessed can. So then we see these kits where, you don't have to, you sort of take out all the guts, you leave the housing in place, and you just take out the lamps, the holders, everything. Just either plug in your power or screw this thing in if it was incandescent, and you pop this up, and now you've got your LED retrofit. And that's pretty good, but it is different. Here's the recessed lamps, no lens. Now we have a lens right at the ceiling plane. That might be okay, but it's going to look different. There are products out there that are more commercial oriented, where you're actually recessing an LED deep into the ceiling. You're going to think that more, so you get good and maybe they cost a lot. All right, discharge. Only 2% of sockets out there in the lighting world are intensity discharge, then about 6% of lighting energy. And that's because of course, this is based on, I think, 2010. So it's, things have changed a little bit, but when the point of the story is that most of these are either 400 watt, 1,000 watt, maybe 250, very high wattage. So there's a lot of potential energy savings out there. One thing you need to be aware of, though, is the light source you're taking out, the high intensity discharge light source, is basically what we call a point source. It's a tiny little spot of light. And that's easy to control. Generally with glare, we can mitigate the glare. We can get good light distribution. We can put that light up, 30, 70 feet in the air and get it to shine, 100 feet away or farther and still get usable light. But LEDs are a little different. They come in arrays. And so here's our 7 watt, 760 lumens. But if I need more light, I need a lot more LEDs. It's a lot bigger, a little big. So just keep that in mind. The size restrictions can be an issue. Plus we have different optics for these. So here's an omnidirectional. We call these sort of corn cob style because they look like a ear of corn a little bit. This one's directional. It maybe makes sense. We put it in a fixture, a shoebox exterior fixture designed to kind of put the light mostly down and out. Here's another directional one. Shoot it out of a fixture. Another directional one if we're trying to send the light down. We're not relying on the optics of the fixture necessarily. But sometimes you want that light to come out in all directions. So here we have a translucent prism. Here we have a solid aluminum reflector. There's a big box retailer that's very particular about how the light comes off of their fixtures. They like the sparkle. They may not find this acceptable. It may be fine in many applications, but you don't want to be surprised. You don't want to do spend an entire weekend retrofitting a big store and then have the client come in Monday morning and tell you that you have to change all 400 fixtures. Here's a case where there's some decorative fixtures. You might recognize this as our, I was gonna say bus tunnel. It's now the transit tunnel. There's a bus though. It tells you how old this picture is. But it's still the same lighting. And so originally they had fluorescent tubes in here, and then they had metal halide light sources in these radiant elements, and then up in here they had some fluorescence and they had metal halide. And retrofit the LED, well, they couldn't get this part to be retrofitted, so they're not glowing. And you can see here they have nice bright surfaces here, but here where there should be light coming, it's darker. That might be acceptable. Here the ceiling's darker. That might be okay, but might not be okay. This is a project that we did where it looked, the client just wanted to ask us, well, what do we think of their proposal? And so they had a very large space. If you look at this space, here's a little person standing here, some 28-foot racking. So we've got this high volume space, lots of fixtures. These were old mercury vapor fixtures, I believe. And they wanted to retrofit them to LED. 72 feet off the floor, 4 rows of 16. There was quite a few fixtures. So first we had to model the lighting and get a sense of what, if they had all new lamps in the thing, what was their, what were they starting with? What was their power? And so they had about 400 watt per fixture, 465. They should be getting close to 30 foot candles, their lighting power density was 2 watts per square foot, 64 fixtures. So the proposal was to put this retrofit in there. They were going to go down to 160 watts. They were going to get 35-foot candles modeled down to 0.7 watts per square foot. So this looks like a big win. They get more light, less power. Let's pop the champagne corks. But one thing to be aware of with this particular retrofit is you have to go up there and bypass the ballast. So they had to send somebody up 72 feet in the air, tinker around with the fixture, bypass the ballast, or drop it down and have it rewired on the floor, send it back up. However that was going to go, it's a lot of work. we're not just taking out one bulb and screwing in another. This is a ballast bypass. So what else could we do? What if we just put in new fixtures, like a real LED fixture? Well, in this case, they used 227 watts. We got a whopping 80 foot candles, and we're 1 watt per square foot. So we're cutting the power by half, but we're more than doubling the light, which seems excessive. So what if we did, and that was for 64 fixtures, but what if we did that same fixture, but instead of putting in 64, we put in 34, because they had kind of a lot to begin with. Well, we get 42 foot candles. Now we're down at 0.5 watts per square foot. We went from, so here they had 0.7 in their retrofit, but we could cut it even less. We buy a lot less fixtures. And by the way, these retrofits at that time, the screw-ins were $300 a piece. So it was real money for those things, and they still had to go up there and rewire. Whereas with this one, they'd just go up and cut down the existing fixtures and put up a new one. But they were buying half of them. So anyway, it doesn't hurt to look a little more closely at any given measure. Okay, here's a pop quiz. I think maybe in interest of time, I'm just going to go through this one. So before doing an LED lamp only retrofit, always check to see which of the following: that the fixture's in good shape, yes; that the lamp is compatible with electronic ballasts and controls, yes; that the optics are appropriate. Doesn't mean that you could change them, but maybe they're changing for the better; that the utility is agreeable, so not all fixtures are going to be acceptable if they're looking at a incentive; and that the customer has enough money. Of course, that should be a primary. No, well, you need to look at the cost. So, all right. Now for the part you've all been waiting for: the Luminaire level lighting control and network lighting control portion of the presentation. So, the Luminaire level lighting controls are a great option for retrofits. It can make it really easy to come in and incorporate all the control strategies in one spot. So why do we use controls at all? Well, saves energy and saves on maintenance costs. So for years we've had sort of the light switch, the lights are on or they're off, and that's controls, but it's kind of a blunt instrument. It may be all you need, but there's possibly better ways to do it. So we look at this space. We've got an occupancy sensor in here, so when someone walks in the room, the lights come on. So here we have the space is occupied, but all the lights are on to full blast. That may not be the most elegant solution. By the same token, we've got only one person working here, and they've got one little pool of light. Let's just say this isn't the best solution either. There's all kinds of reasons why this isn't a great scenario. So what else can we do? And we're able to change the lighting based on the intensity that we want. We can have more light or less light depending on what's going on. We have different occupancy conditions that may drive how we're changing the light. Daylighting conditions are changing, and that may drive that preference. So some people maybe want a certain amount of light, others want different. And then depending on the nature of the task that we're doing. So all these things could dictate how much light and what kind of light we want. And the controls that we deploy are varied now, although similar to what we've had before. We have sometimes the lights just come on or off. Sometimes we manually control the light level. We have occupancy sensors, daylight sensors, and then time clocks where the lights are turned off, on and off automatically. In the old days, we would have different ways of setting, when does the light go off, what does the light level go to, all these little ways of setting it, and it was very complex and tedious. And so simplicity is something we're trying to get to. So in this case, this product is so simple. It's just one button that we use. It seems simple, but it's actually a lot harder, or maybe not harder, but it's just complicated in and of itself. If we want to change the occupancy delay, we have to push this little button. We first have to get into programming mode. We push the button maybe 5 times if we want a 10-minute delay, and then we want to change something else. We have to go to a different platform, different setting mode, and then we maybe hit the button 9 times. It's complicated. We're doing all this sort of pressing the button, and then it'll start flashing to indicate that it's accepted it. Doing all this while the painters are running around, carpets being installed, punch list is happening, possibly a very busy environment, and we're maybe doing it in room after room, space after space, and it's just not a great way to go. So sometimes we have what's called self-programming. That's the goal, right? And here's a case where we've got, we just put the lights in, we go in with a little handheld device or maybe our tablet, we push a button and it programs itself. And that actually works pretty good. I've seen it done. As long as we don't have any hiccups, it works pretty well. But if you have to get in and change anything, it can be a little bit tricky, especially when your interface is like this. We're used to now having interfaces that are a little bit more user-friendly, a little more intuitive, and it can either be on a phone or maybe a tablet or something like that. Another reason we use controls is because code requires it, right? So we've got lighting controls, daylight responsive controls, mandatory in many kinds of spaces. And so here's an office floor, and we're used to having daylight zone, a certain distance from the windows, but now we've actually got primary and secondary daylight zones, and different things happen in those zones. Occupancy sensors. We're used to occupancy in spaces, conference rooms, restrooms, different little individual offices, but now we're actually required to have occupancy throughout pretty much the whole area. We've got egress lighting that we want to be aware of. Maybe certain lights need to do certain things on off hours or when there's an unsafe condition. So the lights are required to have, egress lighting. And we layer all that together and we get a fairly complex between the daylighting, the occupancy, the egress lighting controls situation. So when we look at a space, and you're trying to determine the controls and what's happening with the controls. We walk into, the room is empty, the lights are on. We know that's not good. The room is empty, the lights are off, but there's lots of daylight. That's pretty good, but what happens when the room is occupied? Someone walks in, do the lights just come on anyway? Be good to find out. Well, ideally what we'd have is if we have a daylit space, someone's in the room, but the lights are off. That's a success, assuming the daylighting is appropriate. And so we look at all these controls. There is an exception in the code for Luminaire level lighting controls. We don't have to worry about any of that stuff if we're using those kinds of fixtures. And Luminaire level lighting controls, what are they? Well, each fixture has its own control. That could never happen. But we're used to it in some settings. We have exterior lighting. It has a little photo cell on every fixture often. We've also started seeing in high bay applications where we're putting, especially back when we had the fluorescent, the high output fluorescence, we could start putting control devices on those. We couldn't in the past because of the metal halides or high intensity discharge didn't really start and stop very well, and they certainly couldn't dim very well. So for industrial spaces, it can work pretty well because we've got relatively few high wattage fixtures. So, putting a sensor on there makes sense. You get into an office and you've got lots of fairly low wattage fixtures. putting sensors on all of those, the fixture density is a lot higher. So it was never quite made sense. So a lot of things have come together lately in the last 10, 15 years to make Luminaire level lighting controls viable. One is miniaturization of control devices. We have these controls that are very small now. We have controllable light sources. You know, we could dim fluorescent, but dimming LEDs is a lot easier. Higher bandwidth. So when we try to have network systems, you know, they would could work in smaller areas, but to try to do whole building, it just didn't have the bandwidth to control all that data. And then, of course, we have more demanding energy codes, so we're required to do it in a lot of places. So it, it makes it easier to do it. So what are the advantages? Well, we have, you know, higher granularity of controls, and as we'll see, you can have a little bit of light over here, more light over there, quite easily. You don't generally have to do any rewiring. All these things are, I don't want to say it's plug and play out of the box, but in theory, it is almost that easy. And the ability to rezone. So if you change the use of the space or you move some temporary walls around, you don't have to pull new wire or do anything like that. You just reprogram it. You know, why do we have all this on lighting? Well, one reason we have it is because lighting is a handy place to put all these controls. It's above where we are. It's in almost every space that's occupied by people, and it already has power to it. So we can put all kinds of other controls on there. And so let's take a look at what this might look like from a practical standpoint. So here's another pretty large floor plate. And we've got, we'll look at what happens with some traffic patterns. So let's say it's nighttime and the space is mostly unoccupied or completely unoccupied. And we just want to have a little bit of light for egress just because we feel like it's a good idea and the fire marshal is happy about it and everybody's happy about a little 10% of light in just some of the fixtures. And so we get an early bird arrives. It's comes, you know, while it's still dark out. So someone comes off the elevator, and the lights in the traffic in this area go up to 90%, and the lights in this area. So he comes off the elevator and goes this way. These are on 90%. All these other lights come up to 30%. So the person isn't in a dark space. There's a little bit of light all around, so they can kind of see a little bit. It's not so creepy, but the areas where they actually are lit to 90%. They go over to their desk, and this little area, this little zone is still lit to 90%. It's possible that over time this light will go down to 30% along with the other ones. You could program it so this quarter would stay lit to 90% the whole time if you wanted. So now somebody else comes. Now it's daytime. So we've got our daylight zone, and each fixture in this daylight perimeter has gone to has turned itself off. But these lights are all still at 30%, and someone else has arrived, and our person's still working away, and their light is at 90%. These are 90%, 90%, 90%, because they're outside the daylight zone, and maybe it's summertime. And so we're maybe lightly populated on this floor. Not a lot of people are in. A lot of people are on vacation, so we got people working in each of these areas. It's 90%. We've got daylight coming in. Those areas don't really need any light. Maybe there's a conference room and they've shut the blinds, so these lights come up to 90%. They're doing something with a screen, let's say. So you can see how you get all this really granular control of the lighting. Pretty cool. I love this picture because it really shows that it doesn't have to be just troffers. And we look here and we can see, you know, this person's here, their light's on. But over here, this space is unoccupied, their light's off. Again, person's here, their light's on. We've got some daylight zone here. This light's sort of looks like it's on, but it's just glowing a little bit. All the lights don't actually go off completely, but they glow a little, so that it doesn't look spotty. Or you can set it up however you like when you program it. So there we go. I think we have one more quiz. Katie, I think maybe we'll have you read this one out.
Open this up. Okay, launch. The most effective retrofit luminaire is, and you can choose more than one, energy efficient, has appropriate color qualities, puts light where it's needed, has low operating costs, and or is controllable. Okay, people are voting.
Excellent.
They're quick this time.
Oh yeah. Well, this
And
one's should be easy.
should be easy, yeah. And just a reminder too, we haven't gotten any questions.
Okay.
People still seem engaged, but if you guys do have questions, type them in the
In the chat.
in the little chat box, and we'll get Eric to answer them. Okay, I'm going to close the poll and share out those results. There we go.
Look at that. Bingo. Yes. Yeah, I mean, ideally, all of these things would be in your retrofit. So yeah, and I think we'll finish by just introducing you to some of the local utilities. Obviously, we're part of Seattle City Light, and if you're doing a retrofit, you can call their energy advisor hotline, and they can help you get started if you don't already know where to start. Puget Sound Energy, same thing. They've got an energy advisor 800 number. Snohomish County PUD, give their customer service a call, and Tacoma Public Utilities. And then, if you're working outside that area, or you just don't really, you just want to go to our website, we've got those links to all those on our website under our resources section. Just a heads up, we're going to be rebranding in the next few months. So it may not say Lighting Design Lab, but we'll probably still have these listed for you. So yeah, and I think that is it for my portion. As Katie said, if you have any questions of a lighting nature, or actually any other question, you can give me a call or text me, or yeah, email me. That's what I meant to say. Thank you very much.
Yeah, Erica, oh, you just skipped past Olive, or maybe it just went fast on mine.
Oh, did it go fast? Let's see. There she is.
Sometimes it takes a minute for my screen to show up.
Okay. Yeah,
Yeah, so
Olive the
like
word dog.
Eric said, Olive, she's a good puppy.
She is.
Text Eric about lighting or his puppy or hiking or, the weather.
Yeah.
Or email, and there's his number and email right there, and visit lightingdesignlab.com. It has our upcoming classes, including next week's 2-day energy management systems course. It's Eric's not leading that one, but it's 2 days, but it's only 4 hours, so it's 2 hours on 2 different days. And I was going to say something else along the lines of the rebrand, but I can't remember. Nope, that's it for us. Reminder to take the survey at the end. And the recording will be on the website in a week or less. All right. Anything else, Eric?
No, thank you very much.
Yep. Thank you, everyone, for joining us today. All right. Bye-bye.